this is Mansi Kaushik this side. Today I will be teaching you guys coordination chemistry, which is the most important and most interesting chapter of class 12 in organic chemistry. So if I go into the bookish definition of coordination compounds are nothing but they're the compounds which are formed by combining two or more stable compounds which retains their identity in solid as well as in dissolved state. Now you might not be getting my definition of coordination compound as of now, but you will surely be getting my definition within few minutes. So before jumping on to the topic, I would first like to discuss about some terminology. So first is your addition compound. Now as the name suggests, what are addition compounds? The compounds which are formed by adding two simple compounds together, right? For example, as I have written here, the compounds which are formed by the combination of two or more salts, right? So now these addition compound are further divided into two categories, that is your double salt and your coordination compound. So the coordination compound which we will discuss about in this chapter is nothing but it is a type of addition compound. Okay. So first we will discuss about double salt. Now what is double salt? As again the name is indicating, double salt is nothing but they are the salt which are formed by combining two simple salts. Simple salts like KCl, NaCl. Simple salt you must have studied in class 10th also, right? So for example, here I have taken the example of carnallite. Carnallite is nothing but it is an ore of potassium. Now how it is formed? It is formed by adding KCl, MgCl2 with water, forming KCl, MgCl2 and 6H2O. This is nothing but it is your double salt. Okay. Now if we talk about the coordination compound, here I have taken the example of potassium hexacyanoferrate. It is formed by adding KCN and FeCN2, right? Now you must be wondering what is the difference between this double salt and your coordination compound. So basically this difference can easily be understood with the help of a very simple experiment. For example, if I dissolve this carnallite in water, what I will get is K plus Cl minus and Mg2 plus. What does that mean? That means whenever I am dissolving this carnallite in water, it is getting ionized into its constituent ion, right? Or we can say it is getting dissociated into its constituent ion. Okay, or what else we can say, like it is losing its identity after dissolving in water. But on the other hand, if we talk about this coordination compound, okay, so what do we expect? If I dissolve this in water, what do we expect? We expect K plus ion, 4K plus ion, right? We expect Fe2 plus ion, we expect Cn minus ion, right? But this is not actually happening. Rather, what is happening is we are not getting Fe2 plus ion and Cn minus ion. We are getting only 4K plus ion and this hexacyanoferrate ion. Okay, this, or we can say like after dissolving this coordination compound in water, it is not losing its identity. It is retaining their identity and it is not getting dissociated or it is not getting ionized into its constituent ion. Okay. So students, if I ask you a very simple question, like whether the solution of this carnallite will give the positive test for Mg2 plus, whether it will give the positive test for Cl minus, so your answer will be yes. Why? Because inside the solution we are having this Mg2 plus, we are having Cl minus, we are having K plus, so it will give the positive test for its constituent ion. But on the other hand, if I ask you the same question for coordination compound, will it give the positive test for Fe2 plus ion? So your answer will be no. Why? Because inside the solution we are having no Fe2 plus ion, we are having no Cn minus ion as well. So it will not give the positive test for its constituent ion. Okay. So here also as I have written the definition, double salts are the addition compound which dissolve into their respective ion on dissolving in water. Okay. And what are coordination compound? They are the addition compound which do not dissolve in their respective ion on dissolving in water. So here are some differences I have written in tabular form. So what are double salts? They lose their identity in aqueous solution, as I have told you above, right? And coordination compound, they do not lose their identity in aqueous solution. Second difference is it gives positive test for ion present in them, right? For example, it is giving the positive test for K plus, Cl minus and Mg2 plus. Okay. And like if you add AgNO3 in this solution, it will give the white precipitate of AgCl. Why? Because Cl negative is present as ion in the solution. Now What is the third difference? Okay, that's it. Now the example of double salt is your molar salt and your potash alum. Potash alum you must have heard about, right? Potash alum is nothing but in Hindi we call it fitkari. This is something which our brother or our father apply after the shave, or it acts as a very good antiseptic as well. You can apply it on the cut and it will heal very soon. Okay, and these are some example for your coordination compound. Now our topic of interest is coordination compound. Okay, so before going on to the topic, I would first like to discuss about the representation of this coordination compound, how it is written, and we will also discuss about the naming of coordination compound later maybe in our next video. Okay, so first, how it is represented, how it is written. The coordination compound is written little bit in different way. So basically the representation consists of two parts, that is your ionization part and your coordination entity. The molecules or the which are written inside the bracket is called coordination entity, and the molecule which are written outside the bracket is called ionization sphere. Now as the name is indicated, this ionization sphere is ionizable. This is your ionizable part, while this coordination entity is your non-ionizable part. Sometimes this coordination entity is also called coordination sphere as well. Okay, so for example here, as I have given the example of this K4Fe6, this part is your this part is your ionization sphere, while this bracket part is your coordination entity. Okay, now this coordination entity itself constitute the central atom. This Fe is your central atom and some ligands. Now what are ligands? Ligands are nothing but they are the molecules. They can be anionic, they can be neutral, which donates their electron to the central atom. For example, here I have taken the example of this. Again I have taken the same example, that is your potassium hexacyanoferrate. Okay, and don't worry, we will discuss about the naming of this compound later. Okay, so here this part, the molecule which is written outside the bracket is nothing but ionization sphere. Okay, and this K4 is sometimes also called counter ion. It is also called your counter ion. And the bracket part is your coordination entity or coordination sphere. This coordination entity itself contains central atom, okay, to which the fixed number of molecules are attached, okay, in a very fixed geometry, and the ligands. Okay, what is the role of ligand? Ligand actually donate their electron pair, to central atom. Okay, like here I have written like this. Like again, this part is your counter ion, this is your central atom, this is your CN, this is your ligand. Okay, this is your ligand. Now this ligand actually donate the pair of electron to the central atom in their vacant d orbital and forming a coordinate bond. This is forming a coordinate bond. Now due to this presence of coordinate bond only, this coordination entity even after dissolving in water is remaining intact, or we can say it is not forming any ion. For example, here also what we have seen, like here this Fe2 plus and Cn minus, this is not getting dissociated, right? This coordination entity is not getting dissociated. We are not getting any Fe2 plus or Cn minus ion in the solution. Why? Because this Fe and Cn are strongly bonded with the help of a coordination bond. Okay, now here I have written the definition of coordination entity as well. What is coordination entity? It constitutes the central atom, usually a metal, to which fixed number, I told you only a fixed number of anion or a neutral molecules are attached in a very fixed geometry. Okay, and it is also called your coordination sphere. This coordination entity can also be named as coordination sphere. Now what is ionization sphere? Ions present outside the coordination sphere is called ionization sphere, or you can also call it counter ion as well. Okay, now our next part is central atom. What is the central atom here? Our central atom is iron here. Okay, So what is central atom? In coordination entity, the central atom or ion, usually metal, to which one or more charged molecules are bound by a means of coordination bond, right? Here 6 Cn are bound with the help of a coordination bond, okay? So this is our central atom. Now as I said, the Cn is actually what it is doing? It is actually donating their electron pair. So what is the condition for being a ligand? For being a ligand, it should have a pair of electrons so that it can donate to a central atom. It should have a pair of electrons which it can donate to a central atom. Now what is the condition for central atom? Now if someone is donating an electron pair, now the central atom should have space to, to reside those electron inside them, right? So for that it should have an empty d orbital. It should have empty orbital. So there are some conditions for central atom, like it should be small in size, it should be having high effective nuclear charge, and it must have vacant orbital to accommodate incoming electron. Okay, it should have vacant orbital to accommodate incoming electron. Only then it can accommodate electrons, right? If it do not have any space to accommodate that electron. So that is the basic condition for our central atom. Now these conditions are generally fulfilled by D block element or our transition element. So that is why whenever you see coordination compound, the central atom are basically generally from transition element. Okay. Now what are ligands? Ligands here, what are ligands? So molecules or ion which can donate at least a pair of electron to central atom to form a coordinate bond. Like for example, in this example, our Cn is ligand, right? It is donating their electron pair to the central atom. So this is your ligand. So what does our ligand do? It is doing nothing, but it is donating their electron pair to the central atom, right? So in a nutshell, we can say that as central atom is accepting the electron pair, it is acting as a Lewis acid. Okay, this is a very important point. And the ligand, which is donating their electron pair, it is acting as a Lewis base, right? Because it is electron donor. That is why it is Lewis base. And central atom, it is the electron acceptor, right? That is why it is acting as a Lewis acid, right? So that's all for today's class. In next class, we will be classifying the ligands on the basis of their denticity as well, and we will be discussing about the nomenclature of our coordination compound. Thanks for watching.